All right, ladies and gentlemen, let's find the stationary points for this weird little thing right here. So stationary points. Now, just real quick, the idea with the stationary point is the derivative of the function is going to equal 0 at all stationary points. So those could be turning points where it goes from increasing to decreasing, or the other way around. Sometimes it's a point of inflection. Either way, you take the derivative, you set it equal to 0, solve for x. That's what we're going to do here. So we have to figure out what is the derivative of this thing right here. So we're going to take the derivative of this, so that's going to be negative 9. Now, a lot of the time, when you want to take the derivative, so let's just go ahead, negative 9 minus 81 x to the negative 1 d dx. So there we go right there, right? So we're going to take the derivative of this thing right here. And that's going to be plus 81 x to the negative 2. So there we go. That's our derivative, right? So we could do y prime, however you want to write the notation. Now we're going to take that, set it equal to 0. Negative 9 plus 81 x to the negative 2. Now, it's hard to solve with a negative exponent like that. So one thing I would suggest, let's go ahead and rewrite it. All right, so now watch what happens when we set this up. We're going to add this 9 to move it to the other side, right? We're going to add 9 to move it to the other side. So now we have 9 equals 81, over x squared. Now we can't solve for x when it's in the denominator, but it turns out it's pretty simple to do to get it out of the denominator. We're going to multiply both sides by x squared, because the reason this works is because look at this over here. Those reduce. So we're left with 81 over here. And over here we have 9x squared. So now we've got pretty straightforward deal left, right? All we've got to do is 2 steps. Divide by 9, take square root. Divide by 9, so we got 8x squared equals 9. So when you take the square root, you're going to get a plus 3 and a minus 3. So there's our two x values. We have plus 3, minus 3. Now, those are the x values. We have to figure out what are the y's. So I know I've got a 3, and I know I've got a negative 3, right? So I'm going to take these, plug them into the original equation, right? And see what you get. So let's do the positive 3 first. So we've got negative 9 times 3 minus 81 over 3. So that's negative 27 minus 27. I do believe that would be a negative 54, wouldn't it? Negative 54. Dang, look at that. Now let's do the negative 3. So we've got negative 9 times negative 3 minus 81 over negative 3, right? So that's 27. And then minus a negative again, and 81 divided by 3 is 27, positive 54. So anyway, take your function, take its derivative. If you have an exponent in the denominator and you're taking the derivative, a lot of times it's easier to use that power rule if you rewrite that as a negative exponent. Go ahead and take it, and then to take that derivative, set equal to 0. When you're solving it, if you have a negative exponent, go ahead and put it in the denominator, because when you clean this up, it's pretty easy to use inverse operations. End up with something like this, and there, you're done. So anyway, short and quick. Hope it's been helpful. Have a good night.